Well, at this point you're probably wondering, what exactly is a chemical bond? Well, why don't you sit back and relax and I'll tell you.
Bonds form because of the nature of the valence electron. In an exothermic reaction, heat will be given off into the environment, making it warmer. On the contrary, the endothermic reaction will take in energy and make it colder.
It's just my book! Oh, covalent bonds, yes! Two or more non-metals! They share the electrons! Oh, donkey! Get over here! Give me a boot in the cooker! Fiona! Get out of my swamp!
Follow this chart for whether it's ionic or covalent. The main thing to remember about ionic bonds is that electrons are transferred, and they are transferred because of the high electronegativity differences between the atoms. Covalent bonds occur between two nonmetals, unlike ionic bonds that occur between a metal and a nonmetal. Electronegativity difference between the two elements is generally low in covalent bonds. The greater the E-neg difference, the more ionic in character. The lower the E-neg difference, the more covalent in character. To find the electronegativity difference of a compound, find the electronegativity of each individual atom from your reference table and subtract.
Oxidation numbers are located in the top right corner of each element's box. The most common one is at the top, so when in doubt, use that one. If you need to use a different oxidation number, it'll be notated with a Roman numeral. Rule 1. Uncombined elements have an oxidation number of 0. Rule 2. In compounds, the sum of the charges must be 0. Rule 3. Group 1 metals always have an oxidation number of +1. Group 2 has +2. Rule 4. Halogens are always a -1. Rule 5. Hydrogen is a +1 in compounds unless it is combined with a metal. Then it's a -1. Rule 6. Oxygen is usually -2. When it's combined with elements that are more electronegative, it's a +2. Rule 7. The sum of the oxidation numbers in a polyatomic ion must equal the charge of the ion.
Identify the ions in these polyatomic ions. We'll pause the video real quick. See how you do. So how'd you do? If you didn't get them, you might want to research a little before you test. Dumb. It is imperative, nay, essential, that you remember metals come first and non-metals come second.
Sorry about the tilt.
The Roman numeral refers to how many electrons the metal is giving away. Naming covalent compounds is pretty simple. The number of atoms is unique to each prefix. For example, if there's one atom, the prefix is mono. If there's two, the prefix is
Die, etc.
These are common compounds you'll see on the test. There's most likely going to be a Lewis dot diagram in your final, so know 'em.
What's up?
Hey, dude.
But how do we show which elements are bonded to which? First, you have to find the central atom. In this case, oxygen is the central atom because it has the most unpaired electrons. Next, we draw lines in between each element, connecting the unpaired electrons. A single bond is made up of one pair of electrons. A double bond is made up of two pairs of electrons. And three pairs of electrons, you guessed it, triple bonds.
If there are greater than two atoms, there is an unbonded electron or lone pairs around the central atom.
IMFs, or intermolecular forces, only occur in covalent molecules. They only exist in gaseous and liquid states. London dispersion forces are the weakest of all IMFs. More electrons equals greater LDFs. Hydrogen bonding is a specific type of dipole interaction. It is the strongest of all IMFs by far and only occurs with hydrogen and fluorine, oxygen, and nitrogen.
As referring to the previous slide, it's not FL, it's F, fucking snowman.
Run!
from all of us here at Chemistry Studios, we want to say thanks for watching, guys. What do you think? Guys, good, right? Thanks for watching.
It was fun.
I
Yeah, it's
think
fun.
you could say throughout this whole process,
Yes.
us and the audience,
Of course.
we've bonded.
You suck!
Ron
Ron
Studler.
Alright. No!